and this is no exception. So I had a PhD in automation and robotics, textile and clothing industry in early 90s. And that was the time Marks and Spencer's and other major retailers started globalizing their supply chain. Because at that time, there was a major textile and clothing production in the UK. Most of the Marks and Spencer supply chain was dotted around the north of England and all sorts of. And slowly they started cost cutting and started going with the trend of globalization, which enormously in terms of increasing the choice for customers and bringing the prices down. At the same time, of course, the economy self. Now, the UK economy became more of a services and retail economy rather than economy. That trend continued until very recently. And since 2000, I started focusing more in high-value sector, such as some of the technical textile areas, and more specifically into composites in aerospace, automotive, industrial, and many other application areas. And I also worked with as a visiting fellow at some of the catapult centers in the UK. These catapult centers have been set up in the UK by government. It's a bit like your center of excellence at PhD Tech on a much larger scale to create pockets of industrial relevant centers where you manufacturing and testing facilities that kind of acts as a bridge between innovators and industry, basically to bridge this so-called valley of death. The university or academic or small companies come with ideas, and what that? And there's no funding, or you try to raise funding and you lose momentum, and that idea gets killed. It's at that point of time you need the most support, either in funding or other. So that's where these kind of centers come in. So I will talk briefly about globalization and go for my concept of what is post-COVID. So globalization is relatively last 25 odd years in the history of industrialization is a small period, and this globalization seen an unprecedented integration of supply chain around the world, almost to the extent that it's crossing national geographical boundaries. Companies recognize this and they actually started rebranding themselves. Just to give an example, British Petroleum becomes BP and so on and so forth. They don't want to associate with any specific geographic location. And companies have grown big and powerful, and that made them multinational, whatever you call it. And that helped anyways in terms of reducing the manufacturing costs, increasing the consumption patterns, essentially bringing the products that were only available to elite in the past to masses. And two big markets, India and China, and the rest of the world benefited. Everybody can have a flat screen TV at home. Almost everybody can have a car and air conditioner, so on and so forth. It's a positive side of globalization. And this has been helped by the phenomenal growth. Initially, heavy investments went into fiber optic cables around the world through various intercontinental connections during the dot-com revolution 25 years ago, almost similar time to WTO. And that dot-com actually didn't succeed at the time. They didn't make a lot of money, but the backbone that they created became the platform for globalization. So what happened? Everything, there are some good things come out and sometimes some not so good things come out. For example, massive deindustrialization of the West. US, Europe focused on value in the supply chain. China, for example, heavily in manufacturing, they became truly factory of the world. Initially, the tiger economies of Southeast Asia, like Malaysia, Singapore, Hong Kong, picked up manufacturing, and eventually China dominated this manufacturing sector. On the other hand, India, IT services sector, and have done very well over the period of time. And Europe and for example, and Japan to some extent, but Japan continued to be manufacturing. Germany is another exception where they continue to be a manufacturing power until very recently, and hope they'll continue to lead. And West generally focused on innovation. The general idea was we innovate in the West using top universities, world ranking research, and huge portfolio of IP. Is almost like silver, this IP portfolio. We control the knowledge base, and we give out manufacturing to low-wage economies where the environmental standards are perhaps not as strict as in the West, and they would work for small margins. Obviously, that was the initial script. And West focused on top brands, essentially branding, merchandising, retailing, and essentially interacting with the end users. That's where the major chunk of the profits lie in. It has been great for economies, but people always the script. Obviously, everybody wants to grow up, and the manufacturers can turn out to be a lot more than pure sweatshop manufacturers. Further attention to this book I read back in 1980s, fascinating book, In Search of Excellence by Tom Peters and Robert Waterman. It's kind of alluded to what is great about American corporations at the time. There were some very successful companies like General Motors, General Electric, 3M. Early on, they were all run by very powerful technology drive, and slowly, management, accountants, and managers and administrators started running these companies. Japan became a major power of manufacturing. Obviously, post Plaza Accord, there are some pressures on Japanese economy, and it continued to have an effect on the way Japanese reacted to this crisis to a certain time. So these corporations and really big influences, and they suddenly started focusing on value creation, money generation, big profits. So that led to deindustrialization, creation of so-called rust belts across in the US and to some extent in Europe as well. As I said, Germany kind of avoided to a certain degree, and other countries have more or less. US, for example, is affected far more than elsewhere. Created towns what used to be huge for manufacturing, like Detroit, for example, almost empty, and things like that. And the 1990s World Trade Organization again propelled this trend phenomenally, and it continued even today, and it carried on. You can see the pressures, you can see this. I mean, for example, the trade wars that are currently unleashed by, for example, US-Japan trade war, and many other pressures are a direct result of this extreme move to one direction. I think the globe moves like pendulum. We go from one extreme to other, and the consequences are not always good. What has changed since the so-called golden era of World Trade Organization? Companies, for example, you don't have to name billionaires, but become multi-billionaires, and they're inching towards trillionaires. And difference between the top manager to worker has grown phenomenally. And if you take the salary difference between a top honcho sitting in the US to the factory worker based somewhere in the Far East, the difference is really, really huge. and private equity started dominating the sectors. And these private equity funders have no specific, they just make money in that sense for a good reason, and they give very good returns, but not necessarily good for the manufacturers. And they push the manufacturing to lower and lower margins. But obviously, people quiet. Sweatshops turned innovators. Obviously, people are bright everywhere in the world. Let's not have an assumption that we innovate and the rest of the world sweat. It doesn't work like that. The whole world is becoming smart and innovative. And the early idea was essentially the cheap would be primarily manual, but that doesn't hold anymore. In fact, today there is robots in China than anywhere else in the world. So if you have the power of lower wage and high automation, you can pretty much dominate the manufacturing. And that's what China was able to do. For example, countries like Singapore and other Hong Kong, Taiwan, to a certain degree, are able to do it and reap the benefit of this major globalization of manufacturing revolution. And then, of course, the frictions rise and trade tariff was and weaponization of materials and services. Sometimes suddenly a nation can say, I have this material, then I can strategically take advantage of this, and so on and so forth. And then have this major bomb exploded early this year. And we all went into lockdown, and it exposed the fault lines of supply chain. And suddenly we can't get stuff moving around, even with 10% efficiency. And so most of the world came to a standstill. And obviously it started ticking everybody's mind, what next? That's what everybody's thinking. Localization of supply chains. I'm not saying it will completely nullify the, but there will be a degree of localization, and to what level of localization depends on future pandemics and future crises or future wars, trade conflicts, and so on and so forth. But this of true globalization, I think, ended this year, in my opinion. So economic nationalism and era of tariffs is here to stay. Whether Trump wins the election or not is not going to be the main point. It's a global trend. Another thing everybody noticed now, sustainability, local consumption, circular economy have become buzzwords. You cannot just import a cheap product, use it and throw it in the bin. That's what we have been through the last 20 years. Questions are being asked. How do we make it sustainable? How do we produce? How do we transport it to very short distances with small carbon footprints? How do we and reuse and create a closed cycle economy? In that sense, you can have much better utilization of resources. So how do we achieve it? Everybody, I'm sure India in particular is thinking about technology development localization, and I've heard of some government announcements, and that's happening around the world. Everybody is looking at technology missions, specific areas, technology transfers, local manufacturing, local innovation. All these factors are being considered. And I'll spend about 5-10 minutes on what I talked about and its impact on technical textiles segment. Textiles is again a major globalized sector. Things are produced around the world. In fact, textiles were the early innovators of globalization, creating a globalized manufacturing. And if you to create value chains within geographic locations, either for reasons or for transportation reasons and so on, or having a risk aversion or mitigating the risk in case of crisis, you need to get all these things. To my mind, fiber development comes at the top of this technical. You need to think in terms of creating fiber manufacturing. For example, if India is looking at massive expansion of technical textiles, significant and innovation and investment must go into fibers, starting from glass, carbon, aramids, and ceramics, and all sorts of novel fibers. And there's a room for every type of fibers. More fibers you produce, more cheaply, more growth in the downstream technical textiles. I mean, this is one area where I do a lot of work, so I'm just putting some visuals to stimulate your idea. If you can make carbon fibers at the right price, there are phenomenal number of applications, not just aeroplanes, not just expensive sports cars, but many products that you might use in day-to-day life. But it has to be sustainable. You need to have a closed cycle recycling of applications, where you take one product, use it, for example, aircraft, recycle it and use it in a car, and recycle it, put in a luggage, recycle, and so on and so forth. So you can have a cascade of uses in a kind of a circular economies. And aircraft is a good example, where you start with the highly expensive products, then you trickle down to cars. And the key is the cost, key is the manufacturing volumes, key is the technology. You take a textile fiber, which may be 1 to 3 euros or pounds a kilo, to carbon fibers, which may range from 10 to 30 pounds a kilo, or ceramic fibers may be costing hundreds of pounds of kilo. So you see where value addition comes in. More value addition comes in, more it becomes strategic because of the nature of applications and the value that creates. I'm just quoting some examples of in the Indian context, because it's are from India. Companies like Owen Corning and 3B and companies like that, I believe, make glass fibers. Massive growth in glass fiber production. If you were to massively grow domestic manufacturing sector in things like, in fact, even the composites, carbon fibers are attractive. Glass fibers where the volumes are in terms of pultruded parts, wind turbines, decking bridges, so on and so forth. Unless you have a very low cost glass fiber manufacturing, you cannot achieve a massive growth in application of glass fiber based composites. And aramid fibers, for example, I think the textile secretary, there are global players, and certainly there's no Indian player at this moment, unless I'm not aware of. And in order to create of this nature, a lot of R&D, a lot of innovation, a lot of technology road mapping has to go. And as the leaders in India, institutes like PhD Tech or government missions have to put effort. It's not, you can't do it in piecemeal. You can't spend 3 or 5 years, a few crores, and then forget about it. It has to be sustained over a period of 5, 10, perhaps 20 years until you achieve mission. And it has to happen in many areas, many downstream as well, fiber to fabric to product, and machine development and development. You have to achieve critical technology mass in every sector. Import, you can do technology transfer, and at the same time, you also need to create a domestic base of value addition. Truly, then you can create of a viable critical mass that can sustain a nation's economy for a very long time to come. I'm just giving a few visuals to please your eyes about some of the tech transfer activity center. This is a robotic winding system we developed and commercialized, or in the process of commercialization. 3D weaving patented technologies we are in the process of licensing to companies. For example, this technology creates almost pultruded like 3D woven shapes coming out of the loom. So loom is not a flat loom anymore. Multi-axial weaving or multi-axial fiber placement creates fiber architectures into very complex shapes and significantly cut down the fiber wastage. And multi-axial weaving technology is another area we are working on. And the next stage of product development, where you take these product ideas into industry. For example, these are high-tech aviation fuel pipes we develop with companies, and space fiber We use braiding technology to create these rigid space structures for the cars. I'll take just so I put kind of a roadmap example here for you to think about how government, institutions, and industry play a role. I tried to give an example of how we're doing it in the UK and how you might want to implement, because I've seen a lot of activity going on in India, for example, but can you join up all these jigsaw pieces into one map with stakeholders? For example, the research sector in academic world, the applied research excellence or catapult centers we call in the UK, and industrial partners, and direct industrial development, they all have to be coordinated, lubricated by the government money and with a strategy. So you may, for example, fund 100% research of the institutes, but may do collaborative R&D funding 50% basis with industry COE kind of partnerships, or you scale up for companies through either direct funding or loans and tax breaks, to the point companies are able to bridge that value of scenario and being able to successfully produce. And if you can have this kind of a roadmap, come up with a plan, not just, but I would say maybe 20-year plan, you can achieve anything. Sorry, I've eaten a bit more into the Q&A time, and I'll stop here and we'll take questions and answers. Okay.
Dr. Murugan? Yeah, any questions? Sir, Rangasamy sir is online?
Yes, sir. Yes, ma'am. He is there.
Thank you, Professor Puttluri, for your nice, excellent lecture. Now, the session is open for questions.
Sir, if there is any question in the chat box also, you can read, sir.
So there is one question in chat box, sir.
You can also read.
Okay. Hello, sir.
Yeah, there is one question. What will be the impact of current India-China issues on continuing research?
Can you repeat that?
Can you open the chat, Professor Puttluri?
I think I'm still in the
at the bottom you can see the chat.
The fifth one.
Yes, sir. Yes, sir.
From the left. You just click, the chat will come.
Yes, I can. Okay. Yeah, I've seen Professor Wang's comment on civil aviation. Yes, I agree with the comment. We have already seen a significant effect of decision-making process in the composites industry on the aerospace sector. But I believe this will be it will recover in the next 3-5 years. I mean, nobody is going to give up manufacturing these carbon fiber. The volumes will go down. There will be delays in new launch of new aircraft and so on and so forth. But the current production will be required, and these companies have to work with them at lower volumes. So eventually, I believe it will pull out and it will become even stronger. So I think
that is
fibers to use in wearable textiles. I think to some extent that for conductive pathways, I think carbon fibers, some of the graphene-like materials are being explored to a limited extent in wearables. Obviously, wearables, you may have some problem with carbon fiber brittleness may have an issue, but it has to be properly encapsulated. What are the impacts of carbon fiber? If you do a closed cycle recycling, if you have a sustainable circular economy of carbon fibers, I would say the environmental impact is minimum. At the moment, if you manufacture, create aircraft or anything like that, and then scrap it with no recycling, of course, there's a big environmental impact. But that will not be permitted. A lot of recycling technologies are already in mainstream now, and we are encouraging companies to invest in reutilizing these recycled fibers into new product range. I'm sure it will happen in the next 5 years. So once that happens, truly you will have sustainable carbon fiber or any other fiber composite. Even in technical textiles, you cannot use and throw them. I was listening to comment this morning about diapers and some of these protective face masks and things like that. The era of using and throwing single-use non-wovens, I'm afraid, will be discouraged in future. Somebody screen, okay? How effective is the I think circular economy in technical textiles is fancy. So that needs to be developed further and actually in line with everything else happening in the world. Circular economy, especially important for technical because we deal with higher value fibers. For example, fibers like Kevlar or carbon fibers, able to use it again and again. For example, if you have a protective gear, a firefighter suit, for example, time span, when it comes out, you shred it and make into a brake disc or something like that. I'm just guessing here. So you need to have a cascade of applications. You never plan to use it in the same application. You need to have a cascade of applications. Then you can have a true circular economy.
Any other questions? It's some more questions.
Life cycle analysis, it's not my subject area, but a lot of people are working on life cycle analysis. It's already available. There are life cycle analysis software available where you can put your carbon fibers do reasonably well at the moment, but they can be made better by having a cascade of applications. So you use it at least 10 times before they go into some kind of a landfill, or I mean, hopefully nothing will go into landfill. You go into an application where it stays there. For example, like road building, for example, things like that. The way to recycle. I mean, there are many people trying. You take a parent and maybe shred it and use it in a brake disc. Not necessarily for aircraft, but maybe for motorbike or so on and so forth. So it depends on the suitability. You can do this cascade of applications. Fiber aerospace or shuttle development. Yes, I mean, in fact, you can't. I think it's becoming increasingly clear now. Aluminum airframes will be phased out in not so distant future. It will all be carbon fiber based airframes because of what we have already seen with 787 and A350 programs. So yes, not only you can use, they become the default material systems. The work carried on natural fiber reinforced composites. Yeah, it's a very interesting question. In my opinion, natural fibers have a lot more potential than we are using now because the natural fiber research has been very low key and very low quality, what I have seen so far. Bring it to the same level of investment and development of great potential. I'm not saying natural fiber will replace carbon fibers. There are pockets of areas where you can put natural fibers with the judicious technologies, judicious value addition. You can revolutionize. You don't have to use glass fibers everywhere. Anima probably is not for carbon fiber replacement. Dyneema and Spectra, these kind of fibers are they creep, or they don't have the kind of modular, they don't have the kind of thermal properties, modulus or creep properties of carbon fibers. Every fiber need not replace every fiber. You have systems for types of application ranges, and you have another fiber system for other type of application areas. So you pick the right. So I'm not suggesting one fiber will dominate everything. It's not going to be. And natural fibers will have their own role. Man-made fibers and natural fibers like cotton even may have its own role. You use cotton waste in technical textiles. That's another big possible area. Cotton wind can be used, for example, and so on and so forth. Wool can be used as well as smell absorbency. Professor Wang was talking about absorbing smells and effluents, for example. How effective to use? I know a lot of wastage and herd is actually put in the compost. They don't even use them because there's no market. Markets are. I remember M5. Somebody was asking about M5. M5. I think it takes time, but there are applications. M5 is a great fiber. I remember its development phase in Europe. Then it went to America. I knew Professor Sekma who developed it, and yeah, who are the manufacturer 3D weaving machines? There are companies. For example, Dorier makes 3D weaving machine or making, and I believe other companies will come up. In fact, we have a technology. We aspire to supply 3D weaving technology. If anybody is interested, you can contact me. There are ways to look at the technology transfer. Yeah, service life of composites. There are many methods. We have a whole lot of fracture mechanics, damage mechanics. Everything is available. It is a big academic field. It's not new. People have been working for the last 40, 50 years. In fact, composites flare better than metals in fatigue life. Boeing, when developed 787, said, we don't worry about fatigue anymore. And service life, I mean, some of the winter 35 years ago, almost hand-laying technology are still running in Netherlands and Denmark. So service life of composites is extremely good. Your plastic bottle doesn't degrade where metal starts rusting. That's the kind of an example you can quote. I think Dr. Professor Rangaswamy, I think we have covered most.
Yeah, the time. I think we have, the time is over. Any questions there you can ask through email. Thank you, Professor Prasad Patluri, for your nice and excellent lecture. We all benefited from your lecture. So once again, I thank you on behalf of all other people who are attending. So we give you a big thanks to you. Thank you.
Thank you very much. I thank PSG College for appreciate it.
Thank you, sir, for your excellent presentation. Thank you. The next speaker, sir.
Shall I introduce?
Yes, yes.
So our next speaker is Professor Michael Raj from the Institute of HOF University, and he is going to talk about Concert Master Program in Sustainable Textiles. Professor Michael Ross is a practical engineer. He started careers, practical, covered a lot of practical aspects, and he has joined in academics. So he's a textile engineer with focus on textile finishing and textile chemistry, and a postgraduate student studies in business administration. Before 2002, he had several years experience in textile industry as a dye house manager, and also he was handling R&D related to dye stuff, finishing of chemicals, melt spinning of polyamides. And in 2002, he joined as a professor at Hof University for process technology of textile finishing. His research activities includes sustainability and academic education in textiles. For example, he is handling the HEST project in Bangladesh. He is also involved in repellency of textile fabrics, UV curable coating without solvents, dyeing of industrial fibers, improvement of light stability and light fastness of industrial fibers. And he is a member of many professional organizations like member of German Fastness Committee, Treasurer of IFATCC, International Federation of Association of Textile Chemists and Colorists, and he is also involved in many civic engagement. He is a local manager of German Association for engagement for disabled persons, local manager of German Conservation Organization. Now I request Professor Michael Raj to give his plenary talk.
Okay. Do you hear me? Can you see my presentation?
Yeah, we are able to see.
Yes, yes.
Thank you very much for the kind introduction. First, I would like to make a very short and brief introduction of Hof University. Some of you PSG knows Hof University. Also, some students are knowing Hof University. Here in front, we see the building of our campus in Münchberg. Here, the University of Applied Science Hof was founded around 25 years ago. And University of Applied Science Hof has two campuses, Hof and Münchberg. Between the two small cities, we have a distance of 25 kilometers. The academic textile education in Münchberg is much older. So Campus Münchberg was founded 167 years ago as a Royal Bavarian College for Textile Engineers. And Campus Münchberg has the longest tradition for academic textile education in Germany. Since 2000, Campus Münchberg has been part of University of Applied Science Hof. At the same place in Münchberg, there is also the vocational training for workers in the textile industry for the state of Bavaria. In Germany, we have a special system for training of workers, and there are special schools also for the vocational trainings. And we have a very good cooperation with this school. First, I would like to talk a little bit about basics of sustainability. I think this is very important because for sustainability, we have no universal agreed definition. So mainly you find two different definitions. One from the Brundtland report for the World Commission of Environment and Development, and also another definition by the World Commission of Environment and Development. First means development that meets the needs of the present without compromising the ability of the future generations to meet their own needs. So this definition implements, we have to see today what is the impact on the future. And the second one, there is more related to the production and industry. Here, normally, if you talk about sustainability, you have three pillars of sustainability: social, environment, and economic demands. Very important. You are sustainable if you have a balance between social, economic, and environmental factors. So we will see later also in our concept of a master program, we have to think about social factors. We have also to think about environmental factors, and also very important, we have to think about economical factors. United Nations, they have defined 70 sustainability goals, but very important is you have to look on the whole picture, not to separate one goal. Here, very important is that we have a connection between all the 70 UN sustainability goals. And very important is for our academic program, Master Sustainable Textiles, we have to combine different goals for the program. My colleague before talked about use of industrial fibers for technical textiles. Also very important is here we have some snares of sustainability. Very often you see some monocausal solution and no system orientation. At the moment, we have a big discussion in Europe here, biological degradable polymers versus polymers from natural raw materials. We have a discussion usage of paper bags versus plastic bags for single use. Here, if you have to see the whole life cycle of a product. So therefore, it's very important to have a look also on the resources, on the production, and later on what to do with the waste. Also, a big discussion is about uses of natural dyestuffs, uses as bioethanol as fuel, and rapeseed oil, methyl ester also as fuel. So here we have to think out also about production of food and of the size of our landscape. So very important is here to have a system orientation in the view of sustainability. Therefore, in our opinion, very important for sustainable textile production is we have to think about the human resources. Very important is here to get a sustainability impact on the vocational training, but also on the academic education. We will see later in a slide why, in our opinion, this is very important to look also on the human resources. Here, when we look back, Here I have summarized some UN goals. So you see vocational training also very important is here. We have an quality education. Here academic, the same. We have a quality education partnership for goals. Very important is to think also about responsible consumption and production. The same is for research projects. We have to look also clean water and sanitation, industry, innovation and infrastructure. As the speaker before has focused on innovation, however, is also very important. If you look for sustainability, we have also to look for innovations. And also again here, very important is the responsible consumption and production. Therefore, in our opinion, we have for our bachelor course, Innovative Textiles, we have a combination of vocational training and the academic course. There's a special program in Germany. Here we have a sponsorship for bachelor students from the industry. So they get a vocational training and parallel they get academic training for Bachelor of Innovative Textiles. Here, very important for our bachelor course, also very important for an academic bachelor course is we have a very solid and good basic knowledge, but also here very important is we have to think about when we look on the curricula, what is the content of sustainability, what is the competence orientation. We also are during our bachelor course Innovative Textiles, we increase the demand of competence orientation also in our examination. In higher semesters, we have more competence oriented questions in the examinations. For the master courses, here we get for implementation of this master course, we get the support from the German chemical industry. We get a donation of the German chemical industry to implement this master program. And also here, therefore, we have also the focus in the master course on sustainability and textile chemistry, because the German chemical industry would like to have this combination of sustainability and textile chemistry. And also because also our bachelor course, Innovative Textiles, is an international course. Here we have a cooperation with BSG and also with DKTE. Also, this master course will be an international course. So when I look to the details of a master program, we have to fulfill some preconditions. One of the precondition is that a bachelor degree is needed with at least 180 European credit points or equivalent bachelor degree. Also important is that in the bachelor degree, the applicants have at least 60 European credit points for textile technology and at least 20 European credit points for textile chemistry, textile finishing, textile coloration, or chemistry. Also very important for the preconditions is that there is a proof of English language proficiency. If you have a bachelor degree taught in English with a certificate from the university, you do not need a TOEFL or IELTS certificate. This is very important for the applicants, but also very important is because this is mandatory, because we are a public German university, therefore our students, if they start the program, have to have a proof of basic German language skills. We know at the moment it is a big problem to the COVID-19 pandemic. So to get this certificate, and for next semester we have some special regulation how to get the certificate. Contents, what we will have inside the modules in the master program. Here, one big part is textile production and textile chemistry. Here we have advanced textile chemistry, advanced textile production. Also, we talk about effect and process auxiliaries. This is very important because textile finishing process, you need knowledge about effect and process auxiliaries, and also you need here some input concerning the sustainability of these products. This is related to the pillar, ecological pillar. Then we have a big field here, management and international law. This is more the economic pillar here. We talked about sustainable project management, but also very important, we will see it later, we have to talk about legal framework and digitalization of the textile value chain, because you will see we have a lot of regulations for textile production in Europe, but also worldwide. So very important is to know the background of this legal framework. Then we talk about sustainability and renewable products. Here, very important is when we talk about the circular economy, as you heard before, but also very important is to know the background of certificates and eco-labels. So we have a lot of certificates and eco-labels available worldwide. The students should know what is the basic OSPA requirements. Then we talk about sustainable and resource efficient functionalization and surface modification of textiles. This is also very important to fulfill requirements in the future. When we talk about renewable products for the textile industries, fibers, auxiliaries, and dyestuffs. Before we heard a lot of carbon fibers, the use of carbon fibers for composites. We have big problems in Germany. We have a lot of carbon fiber waste. Once I visited car production in Germany, they have 30% of the used carbon fiber textile materials are waste. What to do with the waste, how to use the waste, how to recycle it. It makes, in my opinion, no sense to grind it and to downcycle it and to make some fire blockers, non-wovens out of it. Here we have to think also. And we have to think about resource efficient application technologies. Here is, we have to think what is the innovations for the future. Then the students can select some electives. At the moment, we have the elective module project simulation, and later on we will have module sustainable products for medical and hygienic end use. Today also at the beginning we heard a lot about medical products and hygienic products. I think this is very important to think about these products because a lot of them are single-use products. Also in Europe, especially in Germany, we have here also a change to multiple used hygienic products also in the hospital because if you have only single use, you have a lot of waste. Then the third semester, the student should have an internship and a master thesis. In total, we have 90 ECTS European credit points for the master program. Here, very important is the implementation of sustainability in the academic education, as this slide you have seen before. Here you see, when you see the textile production chain, you have a lot of raw materials, but you have also at the end a lot of materials. The output, the finished textile fabric is one part of the output. And you see here you have a lot of regulations. You have the UN sustainability goals in Europe, very special, but also very important for importers to Europe. We have REACH and the SVHC list, the list of substances of very high concern. If you use such products, you will have to list the product on the label on the fabric. Also very important, worker protection. Then you have to think about all the eco labels for your finished textile fabrics. Then very important for the wastewater treatment is CDHC, zero discharge of hazardous chemicals, and also zero liquid discharge. I know that a lot of companies, textile mills in India produce according to CDLD. You have to think about this wastewater treatment. Therefore, very important here, in my opinion, we spend a lot of time during the master program for the analysis of the production. Here, very important, in my opinion, is also the chemical management, because if you have a chemical management, you can relative easy make an input and output reduction and optimization. You get a lot of data from the safety data sheets of each product. If you know the consumption of products, if you know the amount of used water, you can calculate the load of the wastewater. And if you can calculate the load of the wastewater, you can optimize your wastewater treatment. Therefore, you see before the module digitalization. This is also very important to make an analysis of your product stream and there to reduce your wastewater. You find an optimized wastewater treatment. For example, in cotton finishing, if you use enzyme treatment as a pre-treatment, here you also influence the wastewater load in comparison to standard process, because the enzymes you are used for the scouring, they also will degrade or reduce the COD and BOD5 value of a wastewater. This is also very important to see this also whole system, and very important are the influences of a system. very important from the economic view of point are the quality requirements. If you produced a textile product, very important is that it has a high quality. You can use it. Next presentation, the speaker will talk about textile waste. This is also a very important problem. If you have high quality textile products, you have less waste. Also very important is color shade and fastness. And also very important is the right first time production. Right first time production means that you look the bulk to bulk reproducibility of your dyeing process, of your finishing process, and also you have to look on the lab to bulk reproducibility to minimize shading, because shading in any way means higher water consumption, higher dye stuff consumption, and also you have a higher impact on the wastewater. Here, when I started my academic education, here we have a principle of end of pipe technology. You think only about the wastewater treatment. Here, we will avoid this. We would like to have a system thinking. Then here, we should also talk about the possible components of a wastewater when you can reduce it. Here you see the three items are linked together. With digital chemical management tools, you can make a calculation of the effluent load and you can optimize your wastewater treatment. In my opinion, also very important in the textile production is separation and aggregation of heavy polluted water and less polluted water. Also very important is if you have less polluted water, use the gray water recycling. Also, you can use here rainwater harvesting, but you have also to look about the quality of the gray water and the rainwater. Here, very important is when we talk about water savings. As I pointed out before, renewable fibers, auxiliaries, and dye stuff also very important. And very important is the resource efficient production. Also to use robots in the textile production. Also to think about combination of different process steps. So when I come to the end of my presentation, I look forward to our discussion and I say thank you for your attention.
Thank you, Professor Michael.
Okay, thank you.
Now the session is open for questions. Professor Michael, can you open the chat box?
Yes, I open chat box.
Yeah, there are some questions are there.
Yeah, I see here, according for the demand of a master course in Europe, yes, there is a demand for the students. With master students of the first semester starting in summer this year, we have a big discussion about the development of the population in Europe. So we have a problem in Europe. We have an elder population, and this was also the topic of the chemical industry. They said to us, we need a master course because we need for the next 10 to 20 years, we need new managers also from outside, not only German managers, we need also international manager. I think in the next 20 years, we will have a very high demand for well-educated textile manager, textile engineers also in Europe. the production in Europe is not so big like in Asia, but very high specialized, and for that we need a very high demand for well-educated people, also young people. Therefore, we have an high demand. For the internship, yes, in last semester, the third semester, if you do the master thesis, this is combined with an internship. Here also we get the donation for the course from the German chemical industry. This is an association of 20 German chemical suppliers, and they told us we will provide some topics and some internships for the students also. Payment, we are a public university. We have at the moment only the standard fees for administration and so on. So there is no additional charge for the master course. Here's a question about research possibilities for antiviral fibers. So in principle, yes, but we have no medicine department and no biological department. So here we have to have a cooperation with a medicine department of another university. We are a university of applied science. Applied science, we are more orientated to practical things and not to such basic research. Here, maybe we have to find a cooperation with another university. I know we have some partners, also Dresden University, that's very famous in textile also. But here you have a medical and a biological and a textile department together, and they are able to do such a research work.
Hello, sir. I have one question, sir.
Yeah.
Sir, during the presentation, in one of your slides as eligibility requirement for the Masters in Sustainable Textiles, you did said the textile credits is about 60. And the textile chemistry coloration part, the number of credits is 20, you said.
Yeah.
Maybe actually we are all working in textile department here. So from the textile side, we'll be able to manage 60 credits for seeking an admission into master's course. But for the 20 credits for the textile chemistry part, I think probably most of the textile technology courses being offered in India will be able to manage only 14 to 15 credits. So we'll be having a shortage of 5 to 6 credits as per your requirements mentioned as the conditions for gaining admission to masters on sustainable textiles. Now, will there be flexibility offered for our students to join this course? Because we will be having only 14 to 15 credits for the textile chemistry side.
Yeah, but here we have a special offer, special for Indian students. We know the problem for the lack of ECTS point for textile chemistry. Here, the students are able to join courses from the bachelor course Innovative Textiles to get the modules to close the gap. And this is very flexible because here our bachelor course Innovative Textiles is also taught in English, so it is no problem for the students to accompany lectures for the lectures from the Innovative Textile bachelor course. So we know it, and we will, if you ask for application, yet we get the admission, but we have to fulfill to close at the end this gap.
For the master's course, sir, after doing BTech in textile technology, for the masters in sustainable,
if you do not fulfill the requirement of the 20 ECTS points for the bachelor, you get admission, but with the requirement to have to join some bachelor courses to fulfill the requirement.
Okay, sir. Okay.
And it's possible because the timetable is so planned that the students are able to do it.
Okay.
We know a lot. I think with PSG is not so big problem, but we know from TKTE there is more weaving and textile production orientated. Here it is maybe a problem. We also have a problem with other universities from abroad because there is no clear conversion factor for your credit points and national credit points and European credit points, but we have discussed it with our examination committee. They say, okay, we will find a way to do it. Yeah, we know it.
Thank you, sir. Thank you, sir.
Okay, because it is different point of view. Yeah, but we are German-based public university. We have to look for the European credit point system, but does not fit Indian credit point, but also not fit credit points from Bangladesh or from other countries. So it is a problem. And also we start the program in summer and we start the program also in winter semester. It's also possible. At the moment, but all of you are members of university, professors at university, and you know pandemic, COVID-19 pandemic is a little bit a challenge. So also for us, so we also know it is a big problem at the moment. German embassies worldwide are closed. It's a problem to get from the applicants to get a visa to Germany. So next semester, I talked to our president, and next semester we will have also a combination of presence lectures and online lectures, and or pure online lectures. We will find a way to cover this problem, but hopefully, but nobody knows. In spring 2021, we have a vaccine for that. We can cover the problem. At the moment, in Germany also, we have rising figures of infections. So we also do not know what's happened at the beginning of October with the new semester. But we now prepared for online lectures. Last semester, in summer semester, we had 100% of the lectures were done online. Also, we tried to make some laboratory lectures. We make a lot of videos for all the laboratory trials and share the videos to the students. We will do our best, but it is nobody knows. I cannot say it's finished or not. We have to wait. Unfortunately, I know.
Okay,
Okay.
sir. Okay.
Thank you, Professor Michael, for your nice, excellent lecture.
Thank you. There's one question left. I see the living expenses.
You can answer one question.
Normally in Germany, it's around 300 to 500 euros per month, depending on the apartment you rent. So, but Münchberg is a small city, and I think you get cheap housings also. It's not another problem. Okay, I hope I have fulfilled or answered all the questions. If do not, feel free, if you have further questions, to send me an email. Thank you very much for your attention. Thank you for the invitation. I was very glad to join the conference. Thank you very much.
Thank you, Professor.
Thank you. Bye-bye. Take care. Very important. Take care. Yeah. Bye-bye.
Bye-bye.
Thank you, Professor Rausch, for joining us.
Thank you.
So, dear participant, now we have to move to the next lecture. This is on the textile waste recycling and challenges. And the eminent person who is going to deliver is Dr. Rangam Rajkova. Rangam Rajkova comes very frequently to India, and he comes for many conferences. So Professor Rangam Rajkova has joined, he has done his BTech from Anna University in BTech Textile Technology, and he has obtained in MTech Fiber Science in IIT Delhi, and obtained his PhD from Deakin University. He is currently working as a senior research fellow in green natural fibers at the Institute of Frontier Materials, Deakin University. He has a research, teaching, and industrial experience. He is CI in Australian Research Council called ARC, Discovery, Industry Linkage, Industry Transformation Research Hub for Future Fibers, and ARC Training Center in Green Chemistry or Manufacturing. He has also leads Cotton Research and Development Corporation and Cotton Incorporated and many industry-sponsored projects. He works with silk-based air drum, which is used for human clinical trials. Dr. Rajkova is a member of the Deakin team and received the H&M Foundation Global Change Award in 2017. He has published research papers in leading journals and he has an H index of 24. Now I request Dr. Rangam Rajkova to deliver his, give his plenary talk.
Can you share this? Can you see this?
We are not able to see.
Yeah, now only it's coming, I think.
Coming? Can you see this now?
No, we are not able to see.
No, sir. No, sir. Not able to see, sir.
Dr. Rangam, you open the PPT.
I did that.
You minimize this one and open the PPT.
Sajesh.
Yes, tell me. Yes, சொல்லுங்க.
சார் சாருக்கு பிரசன்டர் ரோல் மாத்திருங்க சார்.
sir.
It's not coming.
PPT வர மாட்டீங்க.
Yes, sir, it's coming.
I think it's
Sir.
Can you share it now?
வந்துருச்சு சார் வந்துருச்சு
Yes. Yes, sir. Yes, sir. We can see it now.
Okay. Can you hear me, right?
Yes, sir. We can hear
we
you.
are able to hear. Please
Yes,
go
sir.
ahead.
So good morning to those who are in Europe and in US, and good to India, and good evening to Sungai, because it's about 7:30 here in Melbourne. So I first of all I congratulate Professor Tilakavati and the team for organizing this despite all the trouble here, and inviting us to present. So I'm going to present about the textile waste and recycling challenges. In fact, I was in PSC early this year, just before everything happened, and we were doing some work on the industrial textiles recycling projects. But that is a very preliminary work, and the work has got disrupted because of the COVID. But I think that in the future conferences we should be able to present those information. But here I'm just going to present something very general at the moment. So I'll just talk about linear economies in textiles, the current situations. I'll talk about the circular economy in textiles. I'll just pick up two areas. One is on polyester, another is on cotton. Hello.
BSc laser நம்மகிட்ட we have one MSc fiber integrated.
Can you hear me?
ஆமா CAFD.
Ma'am, audio mute, ma'am. Ma'am.
Can you hear me?
Yes, sir. We can hear you, sir.
Yeah, sorry, because something was coming up.
Yes, sir. Yes,
And I'm also going to talk a brief about some of the work that we do here at Institute for Frontier Materials at Deakin University, but that will be very brief. So the issues of the circular economy is all talks coming because of the huge volume of consumption in the last few years in particular, as Professor Plenary said, that globalization has created a mass productions, and the textiles are available for so cheap in price, and in fact in 2017 total items consumed or reached the consumer is about 107 billion. And if you do a small mathematics,
with a current population of 7.8 billion. So it gets a number of 14 of items purchased per year by per person, and that is an average in the world. And you can easily understand that having three-fourths of the poor people in the world. So how much of each one who can afford used to buy clothes, so many items. For example, in the US, in an average, one person buys one pair of clothes, or that much. So if you look at a per person consumption, so I think it's a very recent data where in US each person consumes about 37 kilograms. In Australia comes next, about 27. Europe is a little bit, I think, conservative, and they consume about 22 kilograms. And in the south of Asia and in Africa, it's 5 kgs. But I think this is also growing very, very rapidly, particularly in India. And if you can see the overall the number of people here, that actually is quite a large number. So now because of this huge consumption, this is also creating a huge problem of waste. Now, about 35% of the all materials in the supply chain end up as waste before it's really reaching the consumer. Now, if you know the textile industry, it's about 15%, right? Considering the spinning, the weaving, and even in the garment industry is 15%. But because of the huge population, a lot of extra items are produced is never being used, or many of these items are produced defective and things like that. So in fact, the utilization rate is only about 65%. Now, you globally about $460 billion estimated, fibers is not being used, which could have been used otherwise, and going to the landfill. Now, if you look at again, about 82% of the clothing ends up in a landfill and or burned. So it is a very, very small percentage which is coming back or utilized. For example, in Australia, about 11% according in 2019, all the textiles and the leather goods are being recycled. So even if it is recycled, there's only very, very small proportion actually is going to actually recycling. Now, this is a sort of schematic things that about the linear economy problems and the circular economies from the Ellen MacArthur Foundation, which I actually like this, and that's why I presented here. So in the current model, as in previous speakers also said, what you do is you just take the fibers out. If it is cotton from the soil, if it is polyester or any synthetics from your oil reserves, it comes. We make into textiles, we use it and dispose it. It's a one-way traffic. Now, what happening? We of late we have been trying to do some good things, but we are trying to minimizing the negatives here. So a lot of efforts are going, for example, mostly in terms of trying to save some water, trying to save some energy, trying to reduce the pollutions. So it's a bit of a reduction effect of the negative impacts, but it takes a lot of effort. Now, in the circular economy model, what we are trying to do is with our efforts should give not only to reduce the negative impact, but also gives a positive impact on the whole thing. Now, when you say with our circular economy, so the first thing in the circular economy model in general is the sustainable production system, and that's what's probably in the textile sector, the industry talk about the circular system, as I said again, in terms of reduction of the use of water, for example, in dyeing, or reduction of the energy consumption, or trying to minimize the harmful chemicals or coming out in that side. But this is only one aspect of the circular economy. The other aspect of the circular economy is we should try to see the fibers or the products lasting much longer. It should be repeatedly used. Once it is being used, I mean, there could be concept of sharing economies. There could be concept of something else. As much as possible, the product should be used. Once it is cannot be used, whether it can be repurposed, like it can be utilized for something else, and when it is cannot be done everything is done, then it has to be recycled. The whole idea is that the material should be in the system, should be in the circulation for a long time. And this is something which is missing, and this is something which is need to be done as a part of the circular economy systems. And the third one is, as far as possible, the products or the fibers should come from regenerative systems. Now, in case of cotton, for example, we often say that it is a regenerative fiber. It is not really, because it is going to the landfill and is going as a waste. It is not coming back to the production systems. So and of course, all type of synthetics, they are not regenerative at all. Now, this is something which will take time. The regenerative fibers will take time. But I think what we can do, at least in the medium term, is the second thing. Along with the sustainable production systems, we have to think about how to keep the products or the fibers in the system for a long time. And out of that, recycling is one part of it. So there may be business model in which there can be sharing things, there can be other things, but the recycling is one part which probably we can try, and that is what I'm going to talk in this here today. Now, whatever we do, all the circular systems, it must benefit the business, because without a good business model, nothing will go forward. We talk about environment, you talk about society, it's all good, but it also has to do good to the business. So therefore, there are basically two driving force for going to the circular model. One is the legislations. Of course, that is pushing a lot of industries to be more sustainable, both even in India and elsewhere, because there are regulations which will force the industry to follow that. But at the same time, there has to be a profitable business model along with the social responsibilities, and whether circular economy can do that. Now, this is about recycling. This is again the data I got it from Ellen MacArthur Foundation. As of now, about more than 97% of the textile fibers, the raw materials, come from the virgin feedstock. So about 63% plastic in the sense it is polyester synthetics, and roughly about 25% cotton, and about 11% other things. You get about 2% recycled feedstock from other industries, mostly PET bottle grade fibers, and then only 1% is actually recycled back to the system. So it is, at the moment, it is less than 1% recycled in textiles. And what happens to the rest? Most of they go to the landfill. Something coming back around 12%, but they are going for very downgraded products. For example, mopes or other kind of things. And then the rest of the things are going to the landfill. And if you see here the recycling loop here, so most of the recycling happening at the production stage, back to the production stage, what we call the industrial waste recycling. Hardly there is any recycling from the consumer. This is a very small fraction. So what we have to do eventually is not only the production recycling that should happen from the waste, but there has to be some sort of recycling technology that come to take the waste from the consumer back to the production cycle. Yeah. Now, what are the challenges of the recycling at the moment? Now, one of the key challenges is collection and the sorting systems, because not only we should have a recycling technology, but we should also have a good logistics in terms of collecting and sorting textiles. If you look at Europe, which is leading in this direction, if you look at, for example, in Denmark, out of all the discarded textiles, about 50% is collected. In Germany, it is much better, it's 70%, but rest of the Europe, it's still 20% and much less elsewhere. So in fact, there is no proper collection system, there is no proper sorting systems. And when you talk about sorting, because as we know, the recycling has to be done fiber-wise, so we have to have a good tracing and a tracking technologies. For example, at the end of life, when you have to recycle, we must know which fiber, which the product contains what type of fiber, and there has to be a system to identify that. Otherwise, if that is not there, it's very difficult to sort out and very difficult to recycle. And then one of the critical point of recycling is actually circular design, Because when you talk about circular economy, the design is the first important thing. When somebody design a garment or design a textile product, or even design an industrial textile product, one has to look at designing their product, keeping in mind that that product has to be in the loop for a long time and it has to be recycled. For example, in a typical product, we talk about blend. So if always the blend should be in such a way so that it is easy to separate the fiber component, and if possible, it should not be blended at all. Similarly, color, what set of color are used, whether the color can be recycled, whether there can be more than one colors, a different type of colors that are present, what are the finishing agents are there, whether that is creating a problem. In fact, one of the critical problem of recycling back from the post-consumer textiles is the finishing agents, and also accessories like, for example, buttons, zips, and all these things, whether those can be recycled. And then other areas, like I'm giving in one example is sewing threads. For example, if you talk about a 100% cotton white cloth from an industrial, which is a recycled bag, in the label you will see that it is 100% cotton, but there it might contain a small percent of the sewing threads which are polyester, and that creates a problem in recycling. So when you design a product for a circular economy, that design should be in such a way so the product is designed to recycle. And then finally, there's to be recycling technologies available. So there are not many technologies available as of now, and this is evolving slowly. So what I'm going to discuss is not about all these things, but I'm going to discuss a little bit about the recycling technologies that are available at the moment. So I'm going to discuss only about textiles, only about cottons and about polyester. Why? Because I think it is a graph many of you are familiar. If you see about 50%, more than 50% of the fiber consumed in the industry is now polyester, and about 25% cotton. So cotton and polyester put together account for about 75%. Now, although this is an industrial textile conference, I'm talking about this because this is relevant even for any kind of fibers. Now, if you look at the cotton production over the last 20 years, the production is more or less static. So what is happening is the production of cotton remaining the same, but the percentage is coming down because the entire demand is going up. So what is happening? That is taken up by the polyester. So the polyester is becoming very, very important. So it is also important to understand whether we can recycle polyester properly and how do you recycle it. Now the problems. I'm just giving you one more slide here. So actually, I picked it up again from the Planet Textile Conference in ITMA last year. So this is from Nike. They did all their entire life cycle of a product, their carbon emissions and the water use. Now, if you look at for example the cotton, this is where you have the maximum amount of water consumed, and as everybody knows it. But if you see, it's quite high compared to any other the water use. And then when you talk about this water use, is coming even from the cultivation stage up to the point of washing the garment. So it is entire in a value chain, entire product life cycle. In terms of, if you look at the polyester, mostly it is the energy, but the water uses is quite low. But in general, the both has got problems. So there are a lot of issues around both polyesters and cotton. So we cannot say the cotton is quite sustainable product because it has its own problem. Now, if you see how the cotton and polyester supply will be maintained in the future. Now, if you look at the cotton, we always know that it depends on land. It depends on a lot of water. It depends on the chemicals, pesticides. It depends on a lot of water during the processing and dyeing. Now, all these things have got constraint, and you can minimize this, but you cannot remove this. In fact, this problem is going to be more and more because the land, in particular, the cotton will have to compete with the food production, right? Similarly, if you look about the polyester, so it is only based on fossil fuels, and it requires a lot of energy. Now, if you look at how this is going to be, how the fiber will produce in the future, the problem will be not only from the sustainable production point of view, but whether it will be economically available, whether it will be available in plenty. Now, for example, if you how the future cotton will be cotton will remain as a major fiber, there will be always a problem. So how the polyester will come? I particularly think there will be a big problem of polyester in the years to come because of the whole approach of getting energy from is changing. Now we are moving towards from oil-based energy to a more sustainable or renewable energy systems. Once the renewable energy systems will dominate, what will happen? The oil industry will fall. Oil industry will not be as dominating as of now. The where the petrochemical products will come from, where the polyester will come from. So therefore, there will be a huge impact on polyester because polyester has been a cheap fiber for a very, very long time. And that is one of the reasons why the fibers and the products are available and so cheap. But the polyester may not be available for a very long time like as of today, because one is that there is a limited resource, limited fossil fuel, and second thing is that the the whole energy sector is going to shift. So there will be a huge problem of polyester as well as cotton. So where from this raw material will come in the future? The answer could be, number one, you have to have a new way of producing fibers, relying not much of the land, but something else. So and the that in terms of cotton, I would see, for example, one example I can give you is the bacterial cellulose. The bacteria producing cellulose instead of soil producing it, or you requiring a lot of water. Now, in fact, we have been working with a company in Western Australia. They're having a pilot plan in producing bacterial cellulose. Now, it is still quite expensive, but over a period of time, with the scale, I think that can be one of the cellulosic source producing fibers. Similarly, you have to have an alternate source of producing polyesters or synthetic fibers, which are renewable sources. But that will take time. But in the meanwhile, we have to think of how you keep the existing products for a much longer time so that we do not require a lot of new stock, new fibers. So that has to be, the fiber has to be in the system for a much longer time, and it should be used much more instead of throwing away. Now, these are some of the current technologies available in terms of recycling both polyester and cotton. These are some of the companies that are working on cotton systems, some polyester systems, and some of them are working on blend, because blend is a big problem. Polyester cotton blend, for example, this is the major item. How do you separate it? So I'm just giving you some of the basic technologies that are used for recycling cotton and recycling polyester. In case of cotton, the current approach is mostly mechanical recycling. I'm going to come what about mechanical recycling. All of you more or less, I think, know about this. This is just plucking the fiber out and then trying to spin it again. And the chemical recycling. Chemical recycling is something that we try to dissolve the fiber back into a solution and then spin the fiber again. And the third approach will be waste from non-textile sources. Now, I think when we got an H&M award, there was another group from Italy. They are doing a small, production now using orange peels. For example, there will be a lot of food waste which may have cellulose. So those cellulosic sources can be used to produce fibers. Similarly, polyester. Now, there are two major ways the polyester is recycled. The common method is polyester recycled by heating the polyester. You get a melt and then you spin it again. So that is a very simple system, but there's a lot of problems around there. And the second one is you break down the polyester to an ester or to a basic monomer and then polymerize it back again. And then whether we can find out a renewable stock of polyester to produce it. So these are the general concept around where from we can recycle cotton or recycle polyester. Now let us go and understand a little bit about recycling cotton by mechanical means. Now, what we do is, this is the textile cycle, production cycle. You have a textile manufacturing system, you got a fiber, and then you have the final garment and go to the consumer. Now, most of the recycling is happening here. Now you have the waste in the industry, particularly in the garment manufacturing stage, and those fibers are being pulled out and then used again. So this is what we call as a mechanical recycling, essentially. Now, although this can be done also from the consumer state, it is nothing much happening here. Very, very small proportions. Now, when you talk about chemical recycling, so either from the industrial waste or from the consumer, you have this waste and that you dissolve it into a dope and then spin it into a fiber and it goes back again. And in some cases, as I said, the biopolymer waste from the food waste or anything else, the fiber, the source can come, it can be dissolved into a dope and then can be spun again. So this is mostly about what we call as the chemical recycling, and this is about mechanical recycling. Now, what are the issues with the mechanical recycling that is happening now? Number one, the extraction of mechanical recycling is only possible for cotton. Cannot be done for synthetics because of obvious reasons of generating heat and then it damages the fiber. The second part is the extraction of fiber. It is only possible from knitted garments. The fibers breaks down completely when you try to pull it out from the woven fabric. If somebody can develop technologies which can take out the fibers, retaining their length, which is good, but it's not so easy. And as I said, it's only used for industrial waste, knitted waste, and only from the pre-consumer waste. There's no technology or hardly anybody is using the fibers out from the post-consumer waste. And then when we pluck out the fibers become very short. So the fiber cannot be spun as it is. So there has to be some sort of polyester fiber has to be used with cotton, that is a virgin polyester, and then spun into a yarn. So this is, although it is a recycling, it only can happen only one cycle. It cannot happen the next cycle because the fibers are already short. And again, we are creating a problem because it was 100% cotton. Now it has become a polyester cotton. So how do you separate the polyester in the next cycle? So that is a problem. But in spite of that, it is still becoming a popular thing because a lot of companies are making this as a recycled fiber. In some particularly in Europe, they fetch good value, and then with a recycled certificate, you get a mechanically recycled items. It is not bad. It's happening. Something is happening, not rather than not happening it. And if even in the Coimbatore itself, is about 200-300 tons of these recycled products are produced per day. And why it is happening is mostly because it is happening because these products do not have to be dyed, because the products which are sorted according to the color, and then the fibers are pulled out and then produce the yarns, and it goes to the fabric, but you don't have to dye it again because dyeing is a major cost. So if you can avoid dyeing, so there's an economics there. So as I said, the whole thing in a whole model has to be economically viable, and this is economically viable because of the savings from dyeing, and that is why it is happening. That is successful. It is happening successfully, but again, as I said, it is only happening in only for a very, very limited sector. The industrial waste, that is the waste coming out from textile industry, and only from the knitted waste, and that is only from the single color product, because you cannot segregate the colors again if the garment has got more than two colors. Now, what are the what are the other options? Because to extend the recycling thing, it has to be converted back to a fiber which is good enough, like an original fiber, and it has to be done again and again. So the two options: one is if it's a cotton fiber, either it is a traditional process of viscose process, we can use it to get a fiber, or for which obviously there are problems because viscose is a highly polluting process, uses carbon disulfide and sodium hydroxides. And the other process is the lyocell process. The lyocell process uses a solvent called NMMO, which is a relatively safe solvent, but as of now, only less than around about 4% only is going through the lyocell process. The reason is because the patented technology, I think patent is going out, so the lyocell is going to grow more in the future. The other one is the ionic liquid based process. Now, both ionic liquid based and lyocell process is something having more promising now, because both are sustainable this solvents rather than viscose process. So most of the recycling technologies in the cotton fiber to fiber is happening mostly either ionic liquid based or by the NMMO based process. But ionic liquid has its own problems, and the ionic, sorry, the NMMO and the ionic liquid is still quite expensive. This is an example of the tencel fiber that is from Lenzing. This is a product they have recently launched, which they call the Refriva technology, where they use the wood-based wood cellulose to produce, but then they mix about 25% fibers coming from the textile value chain. This is still coming from the industrial waste, not from the post-consumer waste, and it is only coming about 20% because the technology, it is still not possible to get a fiber out of the entirely from the waste. There are issues like degree of polymerization, how to maintain the viscosity, how to get the fiber quality. Right. But again, as I said, this is only happening from as of now happening from industrial waste, that is the waste from the garment industry. But this probably will be extended to the post consumers in the future, but there are issues like the finishing agents and dyes and all these things in the post consumer textile. So this is not simple as it is. There are other company which is again a pilot scale, which is coming up, Infinite Fiber. I'm not going to go details into it, the production process, and there are some other pilot plans and trial industrial scale production is coming out. One company from Finland is doing it. It's again an ionic liquid based process. So most of the technologies as of now, the problem is the cost and the scalability, and also the sustainability, because we can have the cotton back to a dope and produce a fiber, but it has to be sustainable. Like instead of just for the sake of recycling, we should not recycle. If it creates more problem by using the toxic solvents, by using more energy, that is not going to work. So it has to be sustainable. Even the recycling has to be sustainable, and it has to be cost effective. And that is what are the big problems. Now, very quickly going to the term polyester side of it. Now, polyester as of now, it is mostly coming from bottle to fiber. It is still not fiber to fiber. So you cannot have a polyester fiber, melt it, and then produce another polyester fiber. The reason is the degradation during heating. What is very important for a fiber manufacturing is the intrinsic viscosity. So it depends on the degree of polymerization or from the molecular weight. Now, during this process, the molecular weight drops. So usually the textile fiber grade has got an intrinsic viscosity of 0.4 to 0.7, whereas the polyester water bottle has got a higher intrinsic viscosity of 0.7 plus. You have a soft drink bottles which has got even still higher, and then for example tire engineering plastic. So what happens? Your initial material from which the got to melt and then spin has to have an initially higher intrinsic viscosity or high molecular weight. And that is why we only can use water bottles now to produce a fiber. But in real sense, but it is a downcycling. It is not an upcycling, because you are getting a lower grade product than from a higher grade product. One technology option is once it is degraded, you can use what we call the solid state polymerization or a extension systems to increase the viscosity, but that is still quite expensive. So at the moment, what is happening, only we are getting fibers from the bottles. One is that the starting material has got a higher molecular weight, and the second thing is it's a PO, there's no dyes and there's no chemicals. So these problems are preventing us from yet going from fiber to fiber. So therefore, a thermal recycling process is still not quite viable from going from a textile fiber again back to a textile fiber. So alternate model is the depolymerization, where you can get back to the monomer and then recycle it. So there are a couple of different options. One is called the methanolysis, the hydrolysis, and glycolysis. The glycolysis process is the most promising at the moment. But there are others also trying to get the depolymerization of the polyester and then so that you can repolymerize it. Now, I'm not going to go into details of this, but this is one of the other process that where enzyme is used. This is again a German process. Enzyme is used to get polyester back to monomers, so that these monomers can be again repolymerized. Now, so these are some of the commercial ventures happening at the moment. This is a company which is using an enzyme. The other companies are using either hydrolysis process or glycolysis process to get back to the polyester to monomer. But remind me, I want to remind you again, but most of the things, again, the starting material is the polyester plastics, not the polyester fiber. So there's time again to go from polyester fiber back to the monomer because there are a lot of complexities around here. This is again a recycling of polyester and separating polyester cotton blends. I'm not going to details about this. And then I'm just going to very briefly talk about some of the things that we have been doing at our end here. The one is we are also trying to use waste textiles back to a liquid and then spin, particularly for in terms of cotton spinning. Now this is an example where this is an ionic liquid based process, but because the ionic liquid is expensive, we are trying to use an ionic liquid along with DMSO. There's other solvents to reduce the cost down. And then what we do is we use a colored textiles. Either we can retain the color through a pre-processing stage, or we can remove the color. So accordingly, we can make a colored yarn fiber, or we can make a white fiber. If you use a different type of colors and combine, you can actually create a more library of different type of colors. So some of these things are being mostly done by one of my colleagues. I'm not that much involved in this, but some of the works we have already published, and some other works are going on. So these are some of the properties of the fiber. The fiber's properties we are getting is almost as close as a viscose fiber. The other things that we are looking at is where we had this, the H&M Foundation Global Change Award is trying to get this most of the natural fibers back to the particles. I think I discussed this in our last conference where we can get if you start with a colored textiles, you can get a colored particles, and the particles are so fine that we can use it as a pigment, like for printing. So these are the printed textiles using the colors obtained from already an existing textiles or from a waste textiles. So this is an approach to utilize the dyed fabric for using it. It's essentially is a color recycling. And my last slide, and this is the work we're currently doing now. Now we know that cotton fiber has got all the microfibers inside a fiber, or the nanofibers inside a fiber. Now what if you actually separate those nanofibers and then reassemble again? Now this is, for an example, this is an old cloth. So we have created the nanofibers out of this. If you see this image is about 1 micron. So these are all 100 nanometers or less. And then you can get something like a membrane. But you can also think about assembling those fibers back into a yarn, back into a fiber again. So this is what exactly is done by a company in Spinova, where they use a nanocellulose and then producing a fiber out of it. But the nanocellulose they get it from a wood cellulose. But I think we can also create this nanocellulose from a textile waste, and then put it back. Essentially, what you do is you have the cotton fiber all in nanofiber, separate it and reassemble it back into a fiber. So this is just a concept. Okay, so I just complete this, and then I want to acknowledge the Global Change Award, which helped us to actually get interested into this area, and a project Spark, which is a scheme for promotion of academic and research collaboration, which we have started some work with the PSG College of Technology. But again, as I said, I have not spoken as an expert in this area. This is some of the concept that we are trying to explore, and then trying to see the opportunities around there. So thank you.
Sir, Rangaswamy, sir.
Hello.
Hi, sir.
Yeah. Thank you, Dr. Rangam Rajgova, for your nice and exhaustive lecture. Now the session is open for questions. Could you please open the chat box?
I'm trying to stop. Yeah.
It's open.
Yeah. How much will be reduction in efficiency of those recycled fiber compared to the original one? Would be chemicals used in recycling process. Okay, so it again, as I said, the whole idea will be to have the fibers as good as the new fiber, and that's the whole idea of we should not have a fiber which is poor in quality than the original fiber. That should be the aim. And in doing that, we have to make sure that we are not using any harmful chemicals in the process. What will be the impact of fibers memory on the performance of the recycled fibers, fabrics, and the yarn? So I think it's quite a complex system. Like if you talk about memory, if you are talking about dyes and the pigments, so that again, that's why I said the circular design is the most important thing. So textile is a very complicated system because you have got fibers, different fibers, you've got different dyes, you've got different type of finishing systems. So designing a product, one has to look at every aspects, like what sort of fiber to use, what sort of dyes have to be used, what sort of finishing has to be used, so that it can be separated, or it can be recycled. How the waste management can be done to protective textiles? I couldn't actually really follow these things, but I think we sort of discussed before at the start of the project, even before the COVID started, that if you can actually recycle some of the PP personal protective items, so which is again now becoming a big problem, because we initially talked about face masks, other things, now which is so much consumed and then thrown away. So again, I think if it is eventually all the protective textile will have to be made either degradable or recyclable. So if you have to recycle, so you have to use a fiber which can be recycled. So that could be the answer. Yes, I think I see the industrial textiles as relatively easy to recycle in a sense, because it is less complicated in terms of fiber content, in terms of dyes and chemicals. If it is, for example, personal protective items, it is mostly polypropylene or polyester. So because it is, I think it's less complex, but again, each item has to be looked at its own merit and to be done. But if it is a composite, it is even more complicated. For example, I think it was the carbon fiber composite it was talked about, but once you have a resin and a fiber, how to separate the resin out and how to get the fibers out so the fibers can be recycled. So it's a complex systems again.
I think it is now time. We can wind up. Any questions, you can please ask, write email to Dr. Rangan Rajgova. Thank you, Rangan Rajgova.
Yeah.
Thank you, sir. Thank you, sir. Thank you very much, Professor Rangaswamy, sir, for nicely coordinating the session. Thank you, sir.
Yeah, we can break. Murugan, break for
Ah.
tea. Next session you are to inform.
Ah. Next session.
Murugan, we will resume at 4
Next
o'clock.
session. Timing. Okay, ma'am. Ah. Okay. Okay, now we will break for tea. We'll resume the next session in at 4 o'clock.
Yeah,
Thank you.
Thank you, everyone. Thank you, Professor Rangam. Thank you, Professor Patluri, sir. And thank you, Professor Rausch. Thank you all. Thank you. Hope everything fine, sir. Professor Patluri, sir. No, you have to unmute your mic.
Can you hear me now?
Yeah.
Oh, how are you? Good to see you.
Fine, sir. How are you there, and what about your family?
We're all fine. I mean, we don't have that much of a problem now. Our university is slowly opening. Our researchers are going back to labs.
Okay. Now, okay.
Yeah, things are definitely better.
India is spreading very high.
Yeah, it's quite worrying. You have to be very careful.
Yes. We are not going. We are only working from home.
Yeah, I think that's. I think certainly for some more time. I mean, we are also working from home. We're not allowed to go back to work.
Okay.
Only our researchers can go to the labs.
Okay.
So we're all working from home. But relatively, things are getting better now. I'm hoping it'll happen in India as well in the next few weeks.
Now the cases are less, sir, now?
Yeah, significantly less here.
Oh, very good. Because earlier your Prime Minister and all had, no? Boris.
Yeah. I mean, it went through the phase where a lot of crisis and then suddenly the things are getting better. I'm hoping, I mean, herd immunity is a good thing. I think once it spreads in the community, slowly people become more immune to it. And I think you just need to look after your health. That's the main thing.
Yeah, very correct.
Definitely, it's not a serious problem. I think a lot of people are having problems by excessively worrying about it as well.
Okay.
Worry is not a good thing, and just need to be healthy. And I was telling somebody previously, I think taking good vitamin supplements help as well.
Oh.
Get your health from any problems.
Yes.
And eating well, eating good food, and
exercise, everything. Yeah,
and getting some exposure to sun sometimes is useful.
Yeah.
And
Okay, sir.
This last few months I've been doing lots of gardening, so keeping myself fit.
Okay. Okay, sir. Thank you.
Okay, take care. We'll catch up offline.